All right. Well, Hugh, this is your lunch. You're sponsoring, so yeah, take it away.
Well, just want to say, we're happy to be involved and to support the cause here. Hope the guys at Buster's are enjoying the barbecue. We just want to make sure that everybody knows that we are available when you need us for any questions, any problems, any issues, any needs. We're easy to get a hold of, and I will add my email into my name. So if you can see my name pop up there, I'll put my email in there, and just feel free to reach out anytime. And with that, I'm going to turn it over to Ben from Inovonics.
All right. I'm going to try and share my screen. So let me know if this comes through to you guys. It should be a Inovonics card there. Is that viewable? Somebody
all the way to Auburn, Washington.
Okay. So Inovonics Better Radio since '72. You can see that. Okay. All right. Well, I was asked to do a presentation on something relative, and recently I've been asked to do a presentation on RDS and what are best practices and just questions about that. So that's where I thought we would head today. Let's see if this is working. Okay. All right. There's another picture of me. Okay. My name is Ben Barber. For those of you who don't know me, I'm the president and CEO of Inovonics. Inovonics has been around since 1972, started by Jim Wood and still owned by Jim Wood. So 50 years. We had our birthday party at the NAB this year. So just 2 weeks ago was 50 years for us. Jim started out building limiters, audio limiters for reel-to-reel tape decks so that you didn't overdrive the heads and saturate them. And that's where Inovonics got its start. Then we went into electronics replacement, solid-state replacement electronics for reel-to-reel tape decks, and did a lot of business in that and kept innovating and moved into the broadcast audio processing realm. So that's where we do three main things, and I'll get to that today in just a minute. But for those of you guys who were not at the NAB, and if I was there in front of you, which I would love to be eating barbecue and sharing with you guys in person. Inovonics gives away what we call a swag bag, and this one is our 50th anniversary swag bag. And so if you guys just shoot me an email, put your name and address in there, we will be happy to send you one out. You get a flashlight, you get a charging cable, and of course a catalog. Yeah, we Got to put something in there to make marketing people happy. So that's our swag bag. Ben, Inovonicsbroadcast.com to shoot me an email and we'll get it out to you. So Inovonics, we do three main product areas. We do audio processing, we do monitoring and receivers for either modulation monitors or rebroadcast receivers, all sorts of small receivers. And then we also do RDS encoding, which is what we're going to talk about today. The first question I'm always asked is, what's the difference between RDS and RBDS? And I'll explain that. RDS was the original name of the system, radio data system. It was developed in Europe in the late 70s, and just a way of identifying what program you were listening to, pretty much when it started out. When the U.S. got a hold of it, it was in the 90s when we started doing it, and we renamed it RDS to RBDS, added the word broadcast in there. And really, the only difference is the PTY format codes. And we'll talk about what the format codes are, but on the left-hand side, you can see the RDS standard ones, which are current affairs, education, drama, culture, science, variable, popular music, pop, things like that. That's what the original RDS specification was for, or stated those were. But the U.S., I guess, we wanted to be different, and we wanted to have things like country and sports and talk and religious music, and then we also added in things like Spanish and hip hop. So we varied, but this is really the only difference between RDS and RBDS. So it's just easier to call it RDS, and that's what most people do. So what is RDS? It's a subcarrier. So everyone should be familiar with this. This is the MPX spectrum. You've got your L plus R, you've got the 19 kilohertz pilot there. And then at 38K, you've got your L minus R. And then out here at 57 kilohertz, you have the little double sideband carrier, which is the RDS injection or RDS data. And on this screen, the RDS injection is probably around 5 to 7%. That's what we recommend. If you inject your RDS at, say, 6%, then the FCC generously allows you to modulate to 103%. So you can modulate, over-modulate half of whatever your SCA injection is. If you inject more than about 10% SCA or RDS, some receivers just don't know what to do with that. They're looking for a very specific level, and if the level is too high, they don't work. They stop functioning. So that's keep it 5 to 7%, and that's good. It'll work down to 2 or 3% in your main contour, but if you get out towards the edge and things get noisy, 2 or 3% is just not enough. So 5 to 7 is a good place. So within RDS, there's really 5 things that you need to be aware of. There's a lot of things that RDS can do, but these are the 5 most important things with RDS. The first one is the PI code, or the PI code. A lot of people call it that. It's a program identification. And the PI code is a 4-digit hexadecimal number that's based on your call letters in the US. Other places in the world, it follows different standards, but in the US, the first 4 bytes of the data stream are going to be a 4-byte hex number that is based on your call letter. So WXMB is 929D. KEAR would be 1AA1. KLVM would be 3F3A. And if you're not sure what your PI code is or what it should be, you can go to picodes.nrscstandards.org, and you can type in your call letters, and it will calculate them for you, and it'll tell you. Our RDS encoder does that for you. So if you just type in the call letters, then you're good to go. It'll automatically populate that field. So the PI code is something you need to set. It's unique for your radio station only. And you don't want anybody else in the market having your PI code, and we'll talk about why in just a little bit. The second thing, PTY, program type, and that is just a list of types of different programs that were set up by the NRSC in the US. And often people will say, well, I don't really see a category there that just, exactly hits what we do. And how can I send out a different name? And the answer is you can't. There's 32 of them. They're pre-programmed by the NRSC, and the RDS encoder doesn't actually send out the text of this. All it sends out is the number 10, for instance, and then the radio will receive that and display country on the radio, and it'll know that it's a country station. So if you're searching for country, it will stop on your station. So that's how that works. So it's just the number that's sent out. It's not the words. So in the last few years, we added up around 22. We added public, college, or I should say the NRSC did, public, college, Spanish talk, Spanish music, hip hop. And so there's still two unassigned ones. So if you are ambitious and you don't see one that fits you, you can contact the NRSC and lobby for number 27 and 28. So you can get in on those slots. The next area of RDS that you should know about is the PS field, and it's called the Program Service field. And originally, it's an 8-character field. Originally, it was meant to be static, and it would be something that identifies your station. So for some reason, or for instance, it might be BBC 3 or Live 105 or the B or WXMB FM. So you can do up to 8 characters in the PS field. So that's remember that. The next area is radio text, and radio text is a longer field. It's 64 characters, and it will display differently on different radios, but it's meant to be the dynamic part of RDS. So you would normally put song title, artist information. You might put in your web address, your phone number, or other information there. Eat it Buster's, at noon. Come by and get a free lunch on BGS. So it could be anything like that. So these are some examples. KXYZ 105 or 101 FM. Eat at Joe's Hamburgers, joint lunch all day long. Now playing Only Jesus by Casting Crowns on K-Love. Contact Inovonics. You might put in your phone number, your web address, something like that. So that's what that field, the radio text field, was meant to be. So just remember, 64 characters for radio text. PS is 8 characters, much shorter. So those 2 important things. Alternative frequencies. If you have alternative frequencies, if you have translators, then you should put those frequencies in there. You should put your own frequency and the translator frequencies in there so that as somebody drives through an area, if those overlap, then their radio will change. So here's an example. So you're driving up I-5 and you're picking up 90.7. And as you get to the edge of the 90.7 coverage area and the signal starts getting a little bit noisy, the radio will automatically tune to 88.3, 101.5, and 102.5 and check to see if those transmissions have the same PI code. So that's why it's super important that your PI code be unique. And if the PI code is the same as the station originally being received, the receiver should change frequency, the audio should get better, and everything just keeps on going. So the consumer doesn't realize that they just changed frequencies normally. They just realize, oh, things just cleared up and great, I'm still listening to the same program, same music, everything's great. Where this, some car radios actually have two receivers built into them too, dual tuners. So on those radios, you wouldn't even know that the second tuner was checking other frequencies to see if the signal was better. But in the case of a single tuner, it would check, and it would check very quickly. You would be it'd be pretty hard to tell that it actually even checked the other frequencies. It can check it that fast and get back on, and you just keep on going. So that's how it should work. The thing that you do need to remember is that all RDS radios behave differently. There's no absolute standard on how the receiver is going to interpret or display the information that's being broadcast. So for instance, Subaru Forester, my daughter-in-law has one, it's 2014. And when you tune to a station, it shows the PS, the 8 characters. So it'd be Live 105. And it shows you the Live 105 until it fills up the radio text. So once it gets the 64 characters of radio text, then the display switches to display radio text, and you can never see the PS again unless you tune off and tune back on to the station. That's how that radio works. I have a Ford F-150, 1999, and it only displays PS. You can push RDS buttons. You can do everything known to man on that radio, and all you'll get is the 8-character PS field. You'll never see the radio text field. So Small screens are usually more limiting, like the Subaru and the Ford there in the two examples. Larger screens where you have a large LCD panel, usually those will display both the PS and the radio text simultaneously. So that's a good thing. The other thing to remember is that RDS does not show pictures. I get phone calls all the time from people that said, "Hey, my competitors, got an image, got their logo, or they're playing album art or something, and I want to do that on my station. And how do I do that with RDS?" And the answer is you can't. Your competitor obviously has HD, and they're doing the album art or just a station logo. Hopefully they're doing that at the minimum. But RDS doesn't show pictures. It's just text. So remember that. How do you connect things up? That's a question I always get. So this is our Model 732. If we zoom in on the back, you see 3 BNCs. So you have on the left-hand side, you have a MPX or a pilot input. The center one is RDS only out, and then the one to the right is MPX plus RDS out. You can send data to an RDS encoder, and just about anybody's RDS encoder, via a couple different ways. One is through a serial port, which I wouldn't recommend nowadays, and the other being through a network port over IP. That's the much preferred way. So when you are doing RDS, if you have a stereo pilot, so if you're broadcasting stereo, the FCC says, hey, that 57 kilohertz needs to be phase locked to the 19 kilohertz, which if you do the math, 3 times 19 comes out to be 57. So that's why you have a pilot or an MPX input on this. The RDS encoder will lock to that 19, and then it will, through a PLL loop, generate the 57 kilohertz. It'll be right in sync with the 19. So how do you plug everything in? Connecting it all up, there's lots of different options. I've just got a few here. You can come out of your stereo generator and audio processor with the composite out. You can loop it into the RDS encoder and then take the output of the RDS encoder and run it right into your exciter. So this is a real easy way of doing it. Some people are leery of doing it this way because you're putting your trusted MPX signal through another box, which I have confidence in our box. You may have less confidence in our box, and if our box crashes and burns, you will go off the air. So keep that in mind. Our boxes do have relay contacts in them, so if they blow a fuse or you lose power to the box, it will keep your MPX going right through it and on the air. But something else could happen, and for some reason, caveat emptor, do what you think best. This is another way of doing it. You take the stereo generator and you run the pilot output. Most stereo generators have that. You run it into the 732 RDS encoder, and then you just take the RDS out and back into the stereo gen, and then the mixing is all done in the processor. So in this case, you can unplug your 732, take the power off, you can move it around, you can do whatever you wanted, and it wouldn't take you off the air. So this is probably a little bit better way of doing it, but both ways do work. If you're a mono station, you can just connect up your audio from the audio processor, either AES or just mono. It wouldn't be composite in that case. Run that into your exciter, and then just take the RDS output of the RDS encoder and run that into an SCA input on your exciter. And when I say exciter, you could be doing this to an STL or whatever you would need. But people ask me, where do you place the RDS encoder? And the answer is, if you're stereo, next to your stereo generator. So if that's at the studio site, then that's where you put the RDS encoder. If it's at the transmitter site, or maybe you're running audio up to the transmitter over digital lines or IP or something like that, then you would still want your RDS encoder wherever the stereo generator is located. So that's the answer. So always remember that. So once you get the unit plugged in, the next thing to do is to set it up on a network. And this is the OLED display. You can set up every parameter in the 732 with the OLED display, with a jog wheel and selecting alphabet letters and the on-screen keyboard, but it is very cumbersome, and I would never recommend anybody do that. What I would recommend is you plug it into your network, you go to setup, you go to network, and you go to IP settings, and you find out what your IP is, or you give it an IP, and then you log into its website and do everything through the web interface. That's really the way to do it. When you do put your RDS encoder on a network, whether it's on your station's LAN, or if it's at a transmitter site and it's on a public IP, either way, you always want to give the encoder a static IP address. And the reason is that you want to be able to contact that RDS encoder and know the IP address. You don't want to have the router assigning it something different. And also, if you are sending a dynamic data, artist and song title information, you want to be able to have the automation system always be able to reach the RDS encoder. We get phone calls from people who say, hey, my RDS just stopped working and it's not updating or anything else. And the question is okay, let's look at your automation system and see where it's sending the data. And let's see if the 732 has that same IP address and if it's receiving the data. So that's something. Always set it up for a static IP. Once you do log into the RDS's web interface, you'll see this screen flashing in front of you. And we used to send out, part of our checkout procedure was to put some defaults in there, and we would always put KRDS in for the station call letters. Well, what we found out was that sometimes engineers would get the new RDS encoder, they'd take it out of the box, they'd plug it in, and they would never change the station call letters. And so you might actually wind up with a couple of stations in the same market with KRDS, which translates to a PI code, which then means that more than one station has the same PI code, and a radio can switch back and forth between the two stations. So it's a bad idea. So what we did is we quit putting in a default PI code or a station call letters, and the RDS encoder doesn't put anything out until you put in a PI code. So here's where you do that. Under the RDS settings, you type in WXMB or KEAR or whatever you want. And our RDS encoders calculate the PI code right above it automatically. So that's, you don't have to go to the NRSC website to find what your PI code is. It's very well documented formula and everything. And so we do it. We do it for you. So that's a good thing. So the first thing out of those 5 was the PI code. The second thing was the PTY. And so here is where you set the PTY code. So you just pick from a drop-down menu, and you pick religious talk, or you can set up country or rock or jazz or public or college or Hispanic music. That's where you set that up. So then the next area is the PS field, and that's the 8-character field. And we named it DPS. And the reason we did that is because you can send our encoder dynamic PS. So instead of just being an 8-character field that you would send to the RDS encoder, you can actually send a string. WXMB plays your favorite hits all day long, or the longer you listen, the later it gets, something like that. And then what our encoder will do is it will chunk through that data, and it will try to break things up so that it can display 8 characters at a time, but where they're meaningful. So it will look for spaces between words and break that way. So that's how that works. But DPS field, so you want to put something in there. Our encoder also has DPS defaults. And so you can put in your slogan, you can put in your call letters, something like that. And then right below it, you see DPS timer and minutes. So what we recommend is most songs are 3 to 4 minutes, something like that. Some a little bit longer, most not too much shorter. But you can put in a timer number there of, say, 3 minutes. And so after the RDS encoder gets the artist and song title information, 3 minutes later, if it doesn't have another update, then it will put out your default message. And what's nice about that is, say you go into a commercial sweep or you play the news at the top of the hour, you don't want the last song that was sent to the RDS encoder to be sitting there on the radio faceplate for the next 5 minutes or 10 minutes or however long it is until the next artist and song title comes along. So having a default in there connected to the timer is really good. It just makes the display look so much better. So we recommend you do that. The next field we talked about, we had the PI, the PTY, the PS, and then the radio text field. And again, radio text is 64 characters, and you should put in a default message, and you should also put in the default timer for 3 or 4 minutes, something like that. So whatever you want it to do to go back to your default message after a certain amount of time is always a good idea. And then, there we go. Alternative frequencies. We talked about that. Put in, if you're a single frequency station, put that frequency in. If you have translators, and especially if they overlap, then you definitely want to put in multiple frequencies. Back to that drawing that I had, 3 of the translators overlapped, and one of them was isolated and off to the side, which you can still put the frequency in there, but your radio won't tune to it automatically. So if in that example, if you drove out of the 90.7 coverage area, it wouldn't hang on to that 90.7 unless you just wanted to listen to static until you drove into the 102.5, but you're probably not going to do that. So it has to be overlapping in order for alternative frequencies to switch frequency and for the whole thing to work. So one more time, PI code, program identification, that's based on your call letters. PTY is your format code, rock, country, jazz, college, whatever you broadcast. Your PS, your program service, is the 8-character display, meant to be static, but doesn't have to be static. The radio text field, 64 characters, which is normally meant to be dynamic. If you're going to do dynamic, or if you just want to put your station slogan, address, email, phone number, web address, something like that, you can put that in the radio text field. And then alternative frequencies is where you put in any frequencies that you have for translators, especially coverage. So that's the RDS side, and those are the basic things that you would set up in an RDS encoder. I always like to say that RDS encoders are not overly intelligent. They just simply take whatever information you send to them and put that out over the air. So if you want to do fancy things like advertising and monetize the RDS, you have to have some way of sending that data to the RDS encoder. So just a standard automation system won't play a commercial, won't usually send the RDS encoder text when a commercial plays, or if you wanted to sponsor half an hour or something, it wouldn't do that. So you need some mechanism. The one we used to recommend was Arctic Palm. Arctic Palm is getting sunsetted. There's Q right now, QUU. They do a great job of grabbing the information from your playlist and then sending that to the RDS encoder. They can do add inserts and everything like that. They do that. There's also PadBridge. And then if you have Enco, there's Patapult. And I think Patapult can also do add inserts and things like that. So it's, whatever you're doing, do it well and make sure that the display looks good on all receivers, or as many receivers as you can. So that's something to remember. So now that we've looked at the RDS encoder, let's look at the station automation system. This one is Playlist. It's a lower budget play-out system, but it's a good example of how to set things up. I think every automation system that's modern automation system that's made today or being supported today has some mechanism within it that allows you to send out artist and song title information. So whether that's Next Gen or Simian or DJB or Wide Orbit, I believe every modern current automation system will have a mechanism in it. So this is how you set up station playlist. You go to the tab that says streaming metadata, and then down here at the bottom, you can say, I want to output data via TCP to the IP address of the 732, or it could be your public IP address of a transmitter site. Then you port forward, in this case, port 10,001 through to the encoder. So however you do that, whether it's on your private LAN, public LAN, or public IP, you have to tell the automation system where to send the data. And then you have to tell the automation system what kind of data you're sending it to. What fields should you populate? What fields should you populate in the RDS radio? So remember, there's the PS field. We call it DPS because you can send it more than 8 characters, and then it will chunk through things and make it look right. You could send, instead of DPS equals there, you could put in TEXT equals. Also, our encoder will accept DPS TEXT equals. So if you want to send one set of data to both fields, then you can do that all in one command. So here we see, obviously, the template is sending DPS equals, and then it says %n. And it's like, what in the world is %n? Well, in this case, %n is song artist dash song title. So it's going to send DPS equals, then the artist, and then the title. Looking at this template, you can also add in static information like your call letter. So you could say DPS equals WXMB, and then dash, and then the artist and title information. So it's you can construct that string just about any way you want. And again, automation systems are all different. But most of them have the ability for you to put something together and send to the RDS encoder, so it looks good. So if you look at the station log, you can see here's the log, and if we zoom in, there's an artist and title up there at the top. So in this case, what you would be sending out for the artist name would be Plum, the title would be God Help Me, and the RDS encoder would show it this way. This is the now playing screen on our RDS encoder, so it shows WXMB right there in the PS field, and then we can look at what it would look like. So it sends this out, waits a few seconds, sends the next 8-character block out, waits a few seconds, and then sends the next one out. You can change the timing and the speed of that, so it sends out quicker, or you can send it out slower, whichever you want to do. It's totally up to you. So on a radio faceplate, you would see WXMB dash Plum dash God Help, and then me. And so what it did is the RDS encoder had that entire string, WXMB dash Plum dash God Help Me. And so it chunks it through and tries to make it break nicely in 8-character chunks so that it looks good on the receiver. So God Help, the space does count. So there's 8 characters. And so the RDS encoder was smart enough to break those 2 words or say, hey, I can send those 2 words together, and then add in the me. If you send words that are longer than 8 characters, what happens is the first 8 get put up there, and then they add a character on as it goes across until the entire word is used up or sent, I should say. Sometimes on classical music stations where you have really long names of movements and everything else, it can be a little odd looking, but even there, if you use a third-party software, they should be able to break things where words look nice and present the information better. So I recommend you have something between your automation system and your RDS encoder so that it really cleans things up and looks good. So again, this message was generated by the command DPS equals WXMB dash %N for this. It might be some other variables, but you'd have to check with your automation system to figure that one out. So how's it going to look on radios? Early RDS designs, the scrolling PS, again, this was supposed to be a static field, so it was supposed to be your station Live 105 or the BBC 3, but they were usually pretty prominent, alphanumeric displays. So in General Motors cars, you would see in my head Jason Derulo. On a Chrysler product, it would look like this, and it just says Pearl and then Jam. So the 8 characters would change, rotate as it goes across. So once we got to bigger and bigger LCD panels in the dashboard, and there's some pretty big ones now, a lot more could be done, a lot more could be displayed. So at the same time. So in this one, for instance, you see top 40 up here. Well, that's the PTY code. So this receiver will display the PTY code for you. You see down here Q93Q, that's the PS field, and that's where the station name is supposed to go. And then down here is the radio text. So they're doing also the station logo, or not station logo, but the name of the station, and then the song title and artist information. And there's no right or wrong way whether you're going to put artist first, song title second, or song title first and artist second. You might want to do something like 93Q now playing Michael Jackson, Thriller, and then something else, on WXYMZ or something. So you can mix and match and make it look however you want. That's the point. Here's another radio. So it shows FM 103.3, and then up here at the top you can see where it says Keyshaw, and that's
Toyota radio.
All right. So you can see the PS field up there in the right. So that's the 8 character field. And then down here at the bottom, you've got the radio text. So, and again, they're adding in the hot 103.3 to the artist and song title information. Not everybody listens to their radio in their car. Some people have portable devices. So these are 2 Apple products where you can see that you can tune in, and it shows you the PS field and also the radio text field. And then these are also showing you something called RT Plus, which I'm not going to get into with much depth, but it's a way of where the receiver can actually find your artist name and your song title, and it can break that out separately, and it can put it on a big LCD screen. It might say artist and then your artist name and song title, and put the song title information there. So it can do that. Elsewhere in the world, most everywhere else, cell phones have FM radios in them, and most of those are RDS enabled. So if people are listening elsewhere in the world on portable devices, that's another thing to consider and to look at how your messages are being displayed there. So here's some examples of a Spark radio. I've got one here in the office, so it's real convenient to use. So if you tune in and you have no RDS on it, that's what it's going to look like. So now if you add RDS, you'll see the call letters there, and so it's kind of boring, but it just sits there and plays the music. But then you can also add in the PS. So the static PS right there, CCMB, and you'll see it static. So now you can also, we'll take a look at what it looks like when you're sending a dynamic. And again, this is to the PS field, so it's the 8 character field. So you'll just get snippets of words. So that's what it does. It just takes that message and plays 8 characters at a time. Your PS field and your radio text field can be the same, or they can be different. So in this case, it's different. And now we'll see what radio text and scrolling PS look like. So that's what it looks like when you're scrolling different messages in the PS and the radio text field. So why implement RDS, and is it that hard? No, it's really pretty simple and easy to set up. It identifies your station. It identifies the music or the programming that you're playing. It connects with your listeners with a actual interface instead of just having a frequency sitting there. And tell your marketing people that it's less than a box of T-shirts. So you can, to identify your station and connect listeners, it just makes sense to do. So that's, yeah, do it. If you're not doing it, you should be doing it. So one thing to remember again, Inovonics swag bag, just shoot me an email, ben@inovonicsbroadcast.com, and happy to get you a swag bag. So any questions?
Okay.
We do signal sideband for our stereo subcarrier. When you're passing your MPX out of passing it through, does that interfere with that? Or?
No, not at all. No, the MPX that goes through will transfer right through. It won't do anything to the single sideband. It will just add the 57 kilohertz RDS to whatever's coming in. That's the way it's designed.
Nice.
What's the big difference between a 703 and a 732?
A big difference. 703 is meant to be static, or it is static. So 703 is meant to be programmed once with your station call letters, your slogan, the radio text field, and you program it through USB. You take it to your transmitter site, you plug it in, and it puts out the same message all day long. So 24/7. The 732 is meant to be updated dynamically. So it can take information from just about any source, and it can, as soon as you send it information, it can put it out over the air. The 732 also has a function in it that's called a scheduler. So you can schedule up to 30 different events. So if you're like a college station or something like that, where you have programming blocks throughout the day, or maybe a public station where you're doing all things considered every morning from 6 a.m. to 9 a.m., you can actually put a scheduled event in the 732 and identify programs that way, which is nice. The problem is that you can only do 30, which you might think, oh man, 30, that's incredible, but you can use up 30 pretty quick, especially if you're doing things different on the weekdays and then weekend programming and everything else. So that is something to keep in mind. So,
what's the round number price point between the two?
The 703, I think, is a list price around $600. Hugh, you could probably help me on that. And the 732, I think, is right around $2,500. One other question, or one other comment about the 732. It's connected to your network, and it has a function in it where you can actually whitelist IP addresses, which is real nice, especially if you're going out over a public IP connection, where you can say, look, only receive information from the IP address of my automation. And in doing that, that keeps things, people from getting into it and hacking it as easily anyway, and changing the message on the air. You don't want that to happen. Other questions?
I had an interesting experience
a while back. I just thought if you'd ever run into this. This was with an Audimat, by the way, not one of yours, but everything was fine. I picked up this one portable, and it was suddenly proclaiming that we were mono. I said, we're not mono, we're stereo. Why is RDS saying we're mono? Well, after some digging, I found out there was a byte there that had, like, I think it was an 8-bit byte, but each bit meant something, and it was defaulted to 0, and I had to set the least significant bit to 1 for it to display stereo. Completely hidden. I'd never heard of anything like that. Is that something you've seen before at all?
Yes, that is part of the RDS spec. The RDS might say that you're mono, but your composite would still include the pilot. The FMB80 or FMB80 doesn't remove the pilot or anything like that. So it is a bit, and on ours you don't have to go through and count the bits and figure out which bit you want to make 1 or 0. It's just a checkbox in the interface. So we try to make it easier. You don't have to get down to the, counting bytes and everything like that.
I had a question, Rod Evenson here. I'm supplying program material to all classical, which includes the metadata with regards to artist and the selection, if you will. Some of those get very long, as I've noticed. Does this device, when it is received by a receiver, stream all of that material across the screen, or is it just one truncated segment?
Our PS can handle 128 characters, so you can send the encoder up to 128, and then it will go through it and chunk through it and try to make things fit on an 8-character screen. The radio text will, if you send it more than 64 characters, in our box anyway, it will truncate everything after 64, and that's just the way it is because the receiver can't deal with anything more than 64. So it doesn't play the first 64 and then try to grab the last one. So that's where a third-party software like Q or PadBridge or something like that is real helpful in cleaning things up like that, because that software could do that, where it would play the first 64 for 30 seconds and then show the second 64 and do that. But how it would be displayed on the radio receiver is up to the receiver manufacturer.
Thank you very much.
Mm-hmm.
We had a situation down in Grants Pass when I was there that the RDS unit, when I'd first put it in, unbeknownst to me, it was also doing time synchronization. And I found out when we changed daylight savings, and I got a call from a listener saying, every time I tune to your station, the time changes by an hour. So it's like, I know where that's coming from, so went in and fixed that.
Yes. One of the features of RDS is that it can send out time, and ours has a real-time clock in it, but it also syncs off NTP server. So that's the good thing. And you can check a box in there and tell it, hey, follow daylight savings time. And it will do that. It'll do it. It knows when that changes. So
yeah, once I found that, everything was fine and everybody was appreciative, and even my radio was appreciative. So
yes. Yeah. Well, we all are in our car, and I don't know about you guys, but I mean, it just drives me nuts when I get in somebody's car and the clock is off by an hour because they couldn't figure out how to change it. So if you're doing that with, every time you tune to a station, that would even be more frustrating. So,
Ben, are you familiar with the Toyota radios? I have 2 Toyota products, a Tacoma and a 4Runner. And the thing that's interesting about the radio is that it has a recorder built in the radio. So in other words, if you're driving along and you listen to a newscast and you say, what did he say again? No problem. I can just back up and play back what, it was done before. And it's about a, 10, 15 minute time period. I can go back and play back any part I want. The problem is the clock on the radio may say one thing, but the clock on by the time the radio gets to you is saying something different. So I would hear a sounder for an on-the-air ABC News, and I'd look at the clock and it says 10:10. It took me a while to figure out that this radio is messing with my head. But if anybody has got now you showed a picture in one of your slides of when I mentioned Toyota radio, because I look at that virtually every day. And it's a powerful piece of machinery. But you learn quickly that time is relative. And so I don't know that that particular radio is picking up time information via RDS, because, well, in this case, I'm listening to AM, so clearly it's not. It does have GPS built into it that it normally uses for its time display, unless you're using this delay function that's built in the radio. There's a little scroll. Anybody else have a Toyota radio that can vouch for what I'm saying?
Yeah, I rented, the last time I rented a vehicle in Portland here about 3-4 weeks ago, I had one of those. And the other thing I found about it is if I get onto a phone call, it will pause the radio. And then when I get off the phone call, it started, and I didn't know that to start with. And I heard something come up on my station. It's like, wait a minute, we're way out of sync. And then I realized it was because the radio had picked up. But yeah, I've seen that.
Yeah, that's a mind boggler. If you're not savvy to that, I mean, I can imagine how many dealers get a car come back in and said, you got to fix this radio.
Right. Huh. That's interesting. Yeah.
So you mentioned that RDS is not all displayed the same. Ben, it goes beyond that.
Yes. Yeah, it definitely does. Any other questions, comments?
You have people come to you, Ben, that have individual RDS conundrums, or I've got a project I'm working on that's going to be pretty involved. Obviously, we're looking at your products. I assume there's some sort of you buy our stuff, will help you a little bit more.
Oh, we use TeamViewer every day, and it is a great tool. And yes, we're absolutely happy to help people and do the best we can. Sometimes we can't help you with your automation system, but we can definitely look at it. We can look at your RDS encoder and tell you if things are showing up or not. And yeah, very happy to hold hands and figure things out together. Definitely, Clay.
All righty, appreciate that. I'll be passing that on, I assure you.
All right, thank you. And we speak English, so there you go. That's my one dig. Okay, that's my dig. So.
The manufacturing stereo generators.
Yes. Oh, yes. Yeah. We manufacture stereo generators, audio processors. Definitely.
We use those on our transmitter sites.
Okay. Yeah. Do you feed the audio up there, processed left and right, or do you feed it AES?
Yeah, process when it gets there.
Okay. Yeah.
Have you? Can I go ahead? Yeah. Have you ever worked with an operator that's been using Ovation from Merging Technologies as a player for on-air broadcast?
Not that I remember. Maybe one of our other engineers has, but I'm not familiar with that one.
What about TRE?
Tell me about it.
The broadcast electronics, the radio, the radio experience. Yeah.
Oh, TRE. Yeah, the radio experience. That is another third party site. I forgot to mention them. Yes, TRE is been around for quite a while and used by a lot of stations.
That was developed by Alan Hardle here in Seattle.
Mm-hmm.
the radio experience.
Yes.
And Jump to Go.
Jump to Go. That was another one of his products, right? Good luck in finding schematic diagrams or any documentation if you run into a problem.
See you later.
You want to wrap it up, Hugh?
Yeah, if we're all good, I guess that concludes the presentation. Appreciate everybody showing up, and again, I hope you enjoyed the lunch.
You'll get my bill.
And from Eugene, thank you to both of you, and very good presentation, Ben. And thank you again for presenting for us.
You bet. Glad to be here. Glad to talk to you guys. Wish we could do it in person, and look forward to doing that soon again. So, yeah. And if you want a swag bag, drop me an email, and be happy to get one off to you. Thank you guys for being here.
All right. Thanks.
All right. Take care,
guys.
All right.